Ladies and gentlemen, we are going to add something else to our circle book. We've got central angles, and now we're going to talk about inscribed angles. So I'll zoom this in a bit. We're talking about inscribed angles. Okay. So a central angle goes to the center. An inscribed angle goes all the way to the other side of the circle. We're going to call this ACB. Okay? So what this is saying is inscribed angles are half the interpreted arc. Okay, so if we think of the measure of arc AB, if we divide that by 2, we get the measure of angle ACB. And I'm going to put one more thing about interpreted arcs and inscribed angles, and then we'll go ahead and look at the classwork. So I'm going to move this up just a bit. Okay, if I've got a circle where I've got 2 inscribed angles, okay, I'm going to outline this in orange. So this angle and this angle. Okay, we've got A, B, D, and A, C, D. The measure of angle ABD is equal to the measure of angle ACD because they share the same arc. They share an interpreted arc. So if 2 angles share an arc, if they are inscribed angles, they are equal to each other. That makes sense, right? If this was 50 degrees, each of these would be 25 degrees, right? Because they're half as big, so they would have to be equal to each other. Okay, so we learned 2 things about inscribed arcs. The inscribed arcs are half, the inscribed angles are half the interpreted arc. And if 2 inscribed angles share the same arc, they're equal to each other. So that's the 2 things we learned today.
Can you make it straight?
It's hard because it's a circle, but yes, I can try. The measure of angle ABD is equal to the measure of angle ACD because they share an interpreted arc. So my orange angle is congruent to my purple angle because they share that arc. You guys see they share this arc right here, right? Okay, let's finish this up, and then we are going to look at our classwork. Okay, I'm moving this. I'm zooming out a little bit so we can see this. Okay. Central angle. So we're going to find all the answers to this below. Okay. So in order to do this, you guys are, I'm not going to have you come get a protractor right now. I'm just going to tell you what we got. Okay? So, and it's just for this first one, so we kind of have an idea. So if I were to measure this central angle, RPS, could I tell everything else? So this central angle right here, I'm going to say is 80 degrees. If this central angle right here is 80 degrees, what's this arc? 80, right? Because central arcs and angles are the same. That was last night's homework. Okay, now we've got an inscribed angle. It's R So what is the angle of RTS that we learned from our rules about inscribed angles and interpreted arcs? The arc's 80, so the angle has to be half. So what's half of 80? 40. So this is 40, because you listened, maybe. So this is 40 degrees. Okay, now we've got arc. Let me do it with a different one, different color. RUS. What's the angle of RUS? 40. Okay. So, what is the angle of RVS? What's this one right here? 40, good. So, measure of the minor arc RS is 80 degrees. Okay, do we see that relationship? All those interpreted arcs, they're all the same. All those inscribed angles are the same because it's half the interpreted arc. Yep. All inscribed angles that share the same interpreted arc are equal, and the inscribed angle is half the interpreted arc. Somebody grab the door, please. Okay, so we're going to look at these diagrams below. What do you think is the measure of DAB equal? And what do we think the measure of BCD is equal to? Okay, and we're going to explain our reasonings. All right. So we're looking at angle BCD. So we want to know what this angle is right here. What do we think it is? Okay, so let's look, because we actually know the answer to this, even though there's not a thing there. So I'm looking at this right here. Okay, what's this arc that it shares going to be? What's that orange arc going to be? Yeah, what's the measure? Is it going to be 180, right? So if that's 180, this angle is 90, because it's half of it. And there was no measurement there, and we could do that. Okay? All right. Let's look at the next one. We're looking at angle BCD. What's the angle of that one? 90, right? What's the angle for these? We're going to look at a different one. What's the angle for DAB? 90. Okay. All right. Let's turn it over. All right. We're going to use the inscribed regular hexagon to answer these questions. What do you think the measure is for the central angles? What do we think our measure is right here? And we're not going to use a protractor to check. I'll check for you. Okay. What do the angles of a circle add up to be? 360. And these are all regular hexagons, regular triangles inside my hexagon. So what's each of these going to be? How would we figure that out? We'd go 360 divided by 6, and that's 60. Okay, 60 degrees. What kind of triangles are formed by the regular hexagon? What kind of triangles are these? Are they equilateral, scalene? Are they isosceles? We think they're equilateral, right? Because all the angles will be the same. We also sometimes call that equal angular. All the angles are the same. Okay, so we want to know what arc AB is. If my central angle is 60, my arc is going to be 60. Okay, so what's the arc of BC? It's also going to be 60. Central angles equals arc. Okay, we're going to highlight angle A, B, C, this angle right here. Okay, with one color. And we're going to highlight ADC, ADC with another color. And we're going to figure out the measures. What is the measure of angle ABC? Okay, so we're looking at this arc right here, right? And we want to do half of that. So how many central angles are in there? 1, 2, 3, 4. So we're going to go 60 times 4 gives us 240. And then we're going to divide that by 2. So that angle gives us 120 degrees. That's right here. There's other ways to figure it out. If you figured it out differently, that's fine. Sorry. Okay, now we're going to look at the arc ADC. We just figured that out. That was 240. Okay. All right, do we see the relationship? It's half as big, right? Inscribed angles are half of interpreted arcs. Okay? All right. Let's look at the homework. Okay, so I think you can name inscribed angles and interpreted arcs. Remember, the question mark is the only thing you have to figure out. Sometimes you need to know other things in order to do it for the second part. Okay. Let's do one of these on the back that's a little bit harder. Let's try number 13. Okay. I want to find angle NLM. So I want to find this angle right here. What do I know about that angle? What arc is it going to be half of? N to M, right? So I need to find out what M to M is. How am I going to do that? What does this whole thing add up to be? What is it? 180. So if I go 7x minus 10 plus 13x minus 10 equals 180. I can say 20x minus 20 equals 180. I'm going to add 20 to both sides. So 20x equals 200. Divide that by 20, and I get x equals 10. So now I have to, this is a lot of steps, right? I've solved that part, but that's not my answer. I have to plug it in. 7 times 10 minus 10 is 60. And then what's half of 60? 30. So I don't think it was difficult. You had to know that those two things added up to 180 and that this was going to be half the size of the arc. But then you just had to keep going. You had to solve for x, you had to plug in x, and then you had to take half of your answer. Okay? So that's what the homework is going to be like. If you have any questions, please let me know.